enough. So welcome to my very first PechaKucha-presentation. My name is Stephen Boss, and I research new robots for a living. So in the next 6 minutes, I'm going to take you on a journey about a question that haunts me, because the answer to that question is quite interesting. It changes how every computer thinks. I hope at the end of this presentation you will appreciate why 3 is better than 2. But let's go back in time. Who knew that for 20 years the electric car was the dominant car in the 1800s? Quick show of hands. Only one. Right, that's interesting, right? So now we have Teslas and the electric car, and actually 140 years ago that was already out there. It was the best car. So somewhere we made a wrong decision, right? We took fossil fuel cars. But making a decision, especially at the start of something new, a new technology, if you make a wrong decision, that makes it really hard to sort of go a different direction. Because the impact, if you want to change the wheel, it becomes really hard if you build an entire car, an entire ecosystem around it. So I am researching another fundamental question that is actually wrong, and that is how computers think. Computers think in zeros and one, in binary. It's like a switch, on and off, right? So in the end, computers have to think in zeros and ones. So every mouse click, every key press, every pixel on your screen, everything is eventually translated into a series of zeros and ones, a series of switches. Right, so the technical term for a switch is called a transistor. And with one transistor, we can create 2 states, on and off. Now with 2 transistors, we can create 4 states, on, off, on, off. You can imagine that if we have a computer nowadays with millions, billions of these transistors, it's quite a lot of states, right? And computer engineers, designers, they like that principle. It's so simple, just zeros and ones. But is this really the best? Can't we do better, right? So we're now sort of halfway this presentation, and we get back to the first question. So what keeps me awake at night, and with that my wife as well a bit, is this question: why do computers think in 0 and 1? Why not 3? Why not ternary? 3 states. Because if you look at these glasses, right, it's full or empty, but it could be half full, right? A computer can also think about, I don't know the answer, a 3rd state, because now a computer always has to say it's either true or false. It's either yes or no, right? The real world is not that black and white. So this idea is not new. In the 1840s, a guy called Thomas Fowler invented the mechanical ternary computer already. And then in the 1960s and 1970s, the Russians, they created the Saturn, a first mass-produced electrical ternary computer. So this idea is not new. This is the Saturn. So why did it fail? Because there was a competing technology that was cheaper and simpler, was called binary. And for 40 years, that scaled up. Computers got faster. But we're now at the limits of what we can do in terms of the laws of physics. So this is the end for binary. It's the top, the summit. But you can see in the end, in the distance, there are better solutions. And one of them is called ternary. And to get there, we need 2 technologies that are out there now and were not a lot of years ago. One of them is carbon nanotubes. And these carbon nanotubes, they make it possible that we can create ternary computers that are of the same price as binary computers. So we solve the cost issue. The second thing is that we need to somehow store information. In binary, we call it bits. In ternary, we call it trits. And for that, we use memristors. Now, we can build these ternary computers, but you should ask yourself, why stop at 3? Why not 4, 5, or 6? right? Well, there's a reason, and that's the short answer is Google ternary radix economy, because it's too long to explain the mathematical proof. But you can imagine that if we have a ternary computer, robots will have more energy to do more computations, and for example, this lawnmower cut more grass, make a decision of whether to cut these dandelions. For humans, for us, it means that we have less weighting. We can have devices that are smaller. In general, I would like to say the benefits are 5 C's: computation, compression, comprehension, data consumption, and communication delays. In the end, it means that we can have more data on our hard disks. So when technology is moving forward step by step, it's always important to have a sort of balance. You have to add value. You have to sort of solve real problems. And always remember that while 3 is better than 2, there's always something better, right? Quantum computing might be even better than that. I just started this journey in February with 3 professors and two master students. But it's a long road. So if you're interested, just join me on LinkedIn, write me an email, help me with my research, and hopefully we'll get ternary to a new stage. Because this is where ternary is. It's really in the Stone Age. But you can see 3 persons at the start of a revolution. And I think it will change the world. My name is Steven Bos. I'm a researcher at USN. And I hope you learned a bit more about why 3 is better than 2.